Okay, so let's talk a little bit about some definitions. So hematocrit is a percentage of blood occupied by red blood cells. So once again, if we have our vial and we centrifuge that and we get our plasma, our buffy coat, and our red blood cells, this percentage, the amount that is just this portion compared to the total volume, is your hematocrit. Now, not surprisingly, the range for females is a little bit less or narrower than that of males, and that's primarily due to testosterone levels in males. It increases erythropoietin amounts, which then increases red blood cell count. A couple of other definitions for you. Anemia is simply not having enough red blood cells. Obviously, this would reduce your oxygen carrying capacity, which would then cause fatigue. Conversely, polycythemia is having too many red blood cells. Now, this can also be problematic because this causes a thickening of the blood, which makes the heart work harder, and it can also lead to things like heart attacks or even the thickening of the blood to things like strokes. Now, it would be great if we could have artificial blood so that we didn't have to worry about blood typing and all that kind of stuff, which we're going to talk about in a moment. But why would we want artificial blood as an option? Well, for another thing, blood is not easy to store. So especially in things, in situations like emergencies or like in war zones or things like that, having blood available to injured soldiers is very difficult. So having a good artificial blood that mimics blood would be very beneficial. It wouldn't conflict with people's religious beliefs. Unfortunately, as of right now, there isn't anything that is 100% safe or cost effective. There are some developments. I've given you some links in the slide if you want to read up more about it. There's lots of research ongoing about this because, again, it could literally save lives if we could develop an artificial blood. But so far, nothing has worked to the point where it can become commercially available. So then let's talk about our blood types, what gives us our different blood types, and a little bit about transfusions and who can donate to who and who can receive from who. And we really care about blood typing because if we get it wrong, it can cause something called agglutination. So what you're seeing here on the left-hand side is a standard blood smear where this is good, this is healthy. And you can see this clumping that's occurring in this right-hand image. That is agglutination of the blood. This could be bad. You don't want your blood clumping up like that. Red blood cells not being able to move freely. You can see this can cause things like shock, kidney failure, circulatory collapse, and even death if not immediately remedied. And this is what this image is showing you. So that's called a acute hemolytic reaction. And it starts pretty fast. So wherever that blood transfusion is, again, if there's an incorrect transfusion, it'll feel like it's hot, it's burning. The individual will start feeling the chills, with fever, an increased heart rate. Because again, now we're trying to pump this clumped up blood. The kidneys are going to have a hard time. Kidneys have tiny, tiny, tiny little blood vessels in them that can burst, get damaged. So again, and that leads to then lumbar pain, right? Because that's where the kidneys are located. So again, it can cause death. Bad. So it's really important that we get blood typing done correctly. Now, in today's world, blood typing is done by sophisticated machines, but these sort of old school blood typing cards still work. The way they work is you put anti-sera in these different circles. So this would be against the A blood type, B antigen. The D is also the RH, and we'll talk about what this means in a second, and then this is your control. And if you saw clumping, that would mean that you have that antigen and you are that type. So if you would see clumping in this A, you would have A, B, B. The D would mean you had the RH factor, so you'd be positive. And we'll talk about that a little bit more in a second. And this is just your control. Okay, so I just said all these things to you, so what do we mean? Okay, well, in this chart, what you're looking at, hopefully you can start seeing some patterns fairly quickly. We have our O, A, B, AB blood types, both in the upper row and this lower row. What you'll notice is that the O has nothing, the A has an A marker on the surface, B has a B marker, and then AB has both the A and the B marker. Now those markers are called antigens. Now on the bottom here, again, the O does not have either A or B, but it does have this RH marker, or RH antigen, so we give it a plus. It has that RH. This A now has the A as well as the RH, so we call it A plus, right? B has the B and the RH, B plus. AB has the A, the B, and the RH antigens, so it is AB plus, AB positive, right? So hopefully this is very simple. If it has nothing on its surface, it is O. If it has neither the A or the B but has the RH, it is simply O positive. Only A, it is A negative, A with the RH, A positive, so on and so forth. So that is how we actually type blood. Okay, it's based on the antigens on the surface of each red blood cell. Okay, but red blood cells also have antibodies that are associated with them. Basically, what you want the antibodies, what they're going to do is they are anti-something, right? And what your body will have are antibodies that are anti whatever is not you. Okay? So whatever is you, that's great, and then your antibodies will be whatever is not you. So for example, in this top image, you see the A antigen on the surface of this red blood cell. So in this particular case, if we're being very specific, this would be A negative. So the antibody is basically the opposite of what it is, B. So the antibodies are anti-B. Because again, you don't want these attaching to your own red blood cells, clumping them up, because that's what would happen. If these antibodies were attached to something, it would clump them up. In B-type blood, it'll have antigens against A, right? So again, the thing that is not it. In AB blood, you have A antigen, you have B antigen. So in this case, you can't have either antibody, because if you had B, it would bind to the B antigen. If you had the A, it would bind to the A antigen, so no antibodies. In the O blood, because it has nothing on its surface, it has both anti-A as well as anti-B. Hopefully this makes sense. And this is a very simplified case. We have not taken into account really the positive and negative. We'll do that in the next slide. But conceptually, hopefully this makes sense. Whatever you are, so whatever the red blood cell has on its surface, you have the opposite as far as the antibodies go. Okay, so again, A will have B, AB will have nothing, O will have both, and then B will have A. All right, and then next slide, we're going to complicate this by factoring in the RH. All right, let's see if I can get my handy little tool here to draw. So O negative, this is basically what we saw before. So what antibodies would you expect to have on this? And let's factor in RH. So O has nothing on its surface here, O negative. So I would expect to have an A antibody or anti-A antibody, a B antibody, right? And then I would also expect to see an RH antibody, right? Because these are all the antibodies, these are all the other three options that are not on the surface of the red blood cell. Now let's just go to O positive then. It has RH, so we would not expect to see an RH antibody, right? But we would still expect to see the A as well as the B. Let's take a look at A. It has A, so we would not have the A antibody, we would have B. And again, in this case, we do not have RH, so we'd also expect to see RH. In A positive, we have the A and the RH. So what antibody would we have? Yep, just the B. B will use the same logic. AB we'll use the exact same logic. It just gets even simpler and simpler. So AB negative will simply have the RH antibody. Now, AB positive, will it have any antibodies? Nope. No antibodies. Oh, it's going to take me a long time to write. No, I'm just going to say anti. No antibodies. AB positive is the universal recipient. It can get blood from any of these other blood types, whether it's negative or positive, because it has no antibodies. So it does not have anything that it could possibly react to. Now, conversely, because O red blood cells, O negative specifically, O negative red blood cells have absolutely no antigens on them, you can donate these red blood cells to anybody. So O negative is a universal donor. Okay, so O negative, universal donor, AB positive, universal recipient. Okay, so let's talk a little bit more about blood transfusions. I'm going to show you a very simplified way to think of these things, a heuristic. So O can donate to A type or B type or AB type. A can donate to AB, B can donate to AB. And hopefully this goes without saying, each type can donate to themselves. A negative can donate to a positive, but a positive cannot donate to a negative. Okay, hopefully this makes sense. So an O negative can donate to an A negative as well as an A positive. An O negative can donate to a B negative as well as a B positive. An O negative can donate to an AB positive as well as an AB negative. Again, universal donor, O negative. Now let's just take a different example. Let's say we have an A positive. A positive can donate to AB positive, but again, an A positive would not be able to donate to an AB negative. Okay? So hopefully that makes sense. Similarly, like a B positive could donate to an AB positive, but it would not be able to donate to a AB negative. Because again, positives cannot donate to a negative, but negatives can donate to positives. So a B negative could donate to AB positive or AB negative. Okay. Think about that and let me know if you have any questions about how that works. Again, the important thing here is what antibodies the recipient has, and what you're trying to avoid is those antibodies agglutinizing or clumping red blood cells. Okay, so here's just another way to look at it. So here's the A type RHB. If this individual has the B antibody, it will agglutinize, attach to and agglutinize the blood. And that would be very, very bad. Okay,